Hi, I am Ankur.
And I am Ayush.
We are recent graduates of National Institute of Technology, Raipur, India. This is a project that we have been working on and my bachelor's thesis was a part of it. The title of my bachelor's thesis was Development of an Internet of Things based platform for condition monitoring of machines in view of Industry 4.0. The objective of my thesis was to show that conventional machines like a lathe machine and CNC machines can be made Industry 4.0 enabled by retrofitting them with sensors and IoT gateway.
We have used an accelerometer ADXL345 and Raspberry Pi collects the data from the sensor and sends it to the internet through this router. We have created a web app. Now this shows x-axis, y-axis and z-axis. The z-axis is this one, the y-axis is this one and the x-axis is this one. As we turn on the machine, there would be an initial jerk. Now we can clearly see there is a spike on each of the x-axis, y-axis and z-axis which shows this jerk.
This jerk is basically because of the sudden movement of the machine and its components once we have started the motor. Also, in the time domain spectrum of this signal, we will be able to further see several peaks and valleys, which will represent several imperfections in the spindle as well as some of the problems in various parts of the machine like gear, pulleys, motor, etc. What functionality does this type of a system offer to the end user? Well, it enables the workshop owner or the operators to see real-time process inside of the machines. For example, in this workshop, we have 10 or 15 of machines and we can see the real-time process inside of those machines. If, for example, we create a dashboard or a GUI to a large TV over here, this will enable the end user to see how his machine is performing. And further, you'll be able to set frames and all those features. Similarly, we can also add more sensors to enrich the process inside from their machines. Thank you.
This is the system architecture of our project. We performed experiments on two different machines. The first was a CNC machine. This is a triaxial CNC machine on which we performed milling operation for two different jobs. The first job was made of aluminium and the next one of mild steel. The cutting tool was made of high-speed steel. The second set of experiments were performed on a conventional lathe machine. Same as above, the cutting tool was made of high-speed steel and the job was made of mild steel. We used an ADXL345, which is a MEMS-based triaxial accelerometer, to acquire the data from these two machines using a Raspberry Pi 3. This data was sent using a wireless router to a local machine and to the World Wide Web. On the local machine, we performed time domain analysis. Using this analysis, we found out the root mean square of vibration along the three axes, the standard deviation of vibration, kurtosis, skewness, and many more features. Using the frequency domain analysis, we found out the fast Fourier transform and the spectrogram of the vibration signals to find out the dominant frequencies present in a vibration spectrum. We also predicted metrics like the root mean square of vibration using different machine learning models. On the web application side, we developed a dashboard that shows the triaxial vibrations, that is x-axis, y-axis, and z-axis in real time. All the links to our project are given in the description below. Thank you for watching.